Okay, here we go. We jump right into chapter 2. Now, before we start chapter 2 and go into section 1, I want to tell you just a little bit about what chapter 2 is about. Chapter 2 is essentially introducing kind of reason, logic, and argument to us. So this first section especially is going to be a lot of just kind of understanding. You won't be asked to write many things down. You won't be in this lesson. But what I really need you to do is to make sure that you're listening to what I'm saying and actually trying to process. Since you're not writing down a lot of what I'm saying, I need you to think through what I'm saying and really try to process it as we go. Okay? But we are going to begin to have a conversation about how do we make a formal argument. When we're arguing something, how do we begin to make a formal argument? How do I prove one point? How can I prove my point? How can I debate? Those are all the types of questions that we'll be answering here. And it all starts with the understanding of a conditional statement. So here you'll see the definition of a conditional statement, and you can add this to your definition sheet. But a conditional statement is a statement with a hypothesis and a conclusion. They're written in if-then form. The if part is the hypothesis, and the then part is the conclusion. For example, here is a statement, and this statement says, if I am in geometry at Providence at Johns Creek, then I'm in Coach Kindig's class. So here, this part, the if part, if I'm in geometry at Providence at Johns Creek, is what we would call the hypothesis. That's the condition. That's why this is called a conditional statement. The hypothesis is also known as the condition. If I am in geometry at Providence at Johns Creek, then the conclusion is I am in Coach Kindig's class. And this statement is true, and the reason this statement is true is because there's no one who takes geometry at Providence Johns Creek without being in my class, in Coach Kindig's class. So this is an if-then conditional statement where we have a hypothesis and a conclusion, and they're written in if-then form. Why do these matter? Because a lot of the statements that we make based on facts are conditional statements. Let's look at a few here. Not all conditional statements are given in if-then form. For example, look at this one. It says 2 points are collinear if they lie on the same line. That's just the definition of collinear points. Collinear points lie on the same line. This is not explicitly written in if-then form, but it is still a conditional statement. If we were to rewrite it in if-then form, how would we rearrange this? I want you to answer this in your own head. How would we rearrange this conditional statement so that it would be in if-then form? Well, the answer, of course, is if 2 points lie on the same line, then they are collinear. Okay, so this is still a conditional statement just because it's not explicitly written in if-then form. Look at this one as well. All girls are smarter than boys. Is that a conditional statement? Yes, it is. Where is the if and where is the then? It's not explicitly written, but if we really look at this statement, all girls are smarter than boys, there is a condition there, and that's this. If you are a girl, then you are smarter than boys, right? So even though it doesn't say if then, there's still a condition behind here, and the condition that it implies is that if you're a girl, then you are smarter than boys. And here we have another one. The sum of supplementary angles is 180 degrees. Where is the if then? Take a second, pause the video, and find the if then statement that's hidden within this conditional statement. Okay, so hopefully you've taken a little bit of time to try and figure out where the if then is here. If we write it as an if-then, we could write it, one of the ways we could write it is like this. If angles are supplementary, then their sum is 180 degrees. Okay, so we can write conditional statements a lot of different ways, but in each of these statements, there's always a condition hidden behind. Okay, there's also something called the converse of a conditional statement. And once again, you could add this to your definition sheet, and if you need to pause the video to have time to do that, go ahead. But the converse of a conditional statement is when you switch the hypothesis and the conclusion. Okay, so let's take a look at some examples here. If I have the statement, if two segments are congruent, then they have the same length. Okay? If two segments are congruent, that part is the hypothesis. That's the if part of the statement. And so, of course, the conclusion is then they have the same length. That would be the conclusion. If I flip-flop those, that would give me the converse of this statement here. So if I flip-flop them, it says, if two segments have the same length, then they are congruent. And that is also a true statement, right? Just because I'm flipping the if and the then doesn't necessarily make it true. So now I've made the if the then and the then the if. The hypothesis and the conclusion are switched, and the statement would be, if two segments have the same length, then they are congruent. So this is the converse. This is called the converse of a conditional statement. Now, why are we doing all of this? It's so that we can make argument. Let's look at an example here, and we're going to look at a couple of examples, and then we're going to be done. Determine the following. Is the conditional statement true? If not, give a counterexample. Is the converse true? If not, give a counterexample. Let's look at this one. If x equals 4, then x squared equals 16. Is this conditional statement true? Well, if we take 4 and if we take x and we square it, we get x squared. And if we take 4 and we square it, we get 16 squared. So yes, this conditional statement is true. But let's take a look really quickly at the converse. So this conditional statement is true. What would the converse say? The converse, and I'll write this out, the converse would be this. The converse would be if x squared equals 16, then x equals 4. Now, is that statement true? Well, actually, when you think about it, if I solve this statement right here, x squared equals 16, let's solve this up here. In order to get x by itself, I would need to take the square root of both sides. And if you remember, when we take the square root of something, we get both the positive and negative versions of that number, because here x could either be 4 or it could be negative 4, because 4 squared is 16, but negative 4 squared is also 16. So the converse of this statement is not true, and the counterexample would be x could equal negative 4. If x squared equals 16, then x could be negative 4, and that would make this converse not true. So just because the conditional statement is true, where we're saying the hypothesis is x must equal 4, so then x squared equals 16, that is true. But just because the conditional statement is true does not necessarily mean that the converse is also true, and this is an example of that. Let's look at a couple more examples. If B is between A and C, then AB plus BC equals AC. That is a postulate. That's a postulate that you know. That is the segment addition postulate. And when we look at a postulate, and if it's written as a conditional statement, we can say that postulates are always true, but the converse might not necessarily be true. Okay, so that's just something to keep in mind, that postulates will always be true in the forward direction, but if I write their converse, that might not necessarily be true. Okay, so keep that in mind. And then here is complementary angles sum to 90 degrees. That's the definition of complementary angles. And what we know about definitions is definitions are always true both forwards and backwards. So we could say if I have a complementary angle, then if I have two angles that are complementary, then they sum to 90 degrees. Or I could say if two angles sum to 90 degrees, then they are complementary. That is both the conditional statement and its converse, and both of those statements are true. Okay, so definitions are always true forwards and backwards. Okay. So that was just a quick little 9-minute overview of conditional statements. Before we go, what we're going to do is we're going to go over 3 postulates, and that's postulate 5, 6, and 7. And remember, if you remember what a postulate is a rule accepted without proof. Okay, so we don't really need to prove it. It's just kind of common sense. So postulate 5 says, through any 2 points, there exists exactly one line. So basically, there's only one line that will go through both these points, A and B. I can't draw another line that somehow goes through A and B. Then see, that's not a line. There's only one line that exists that would go through both points A and B. A line contains, postulate 6, a line contains at least 2 points, right? I cannot have 1 point and call it a line. That's not a line, that's a point. So in order to have a line, I have to have at least 2 points that are connected. That's what qualifies it as a line. Okay, once again, that's kind of accepted. And then last, postulate 7, if 2 lines intersect, then their intersection is exactly 1 point. So here we have 2 lines intersecting. The point that they intersect is exactly 1 point, no more and no less. Okay, so this is 1 point, and this is their intersection. All right. So that's section 1. That's all there is to it. There will be some brief practice problems. I hope you understood. If you have questions on conditional statements and their converses, come ask me. Your homework will be dealing with having you write conditional statements and turning certain statements into conditional statements. It shouldn't be too hard. And as always, let me know if you have any questions. Thanks. Bye.